Good day, ma'am. Example 12.7. Comprehensive stress in a pillar. A sculpture weighed at 10,000 Newton rests on a horizontal surface at the top of 6-meter tall vertical pillar. The pillar cross-sectional area is 0.20 meters square and it's made of granite with a mass density of 2,700 kilogram meter cube. Find the comprehensive stress and the cross section located 3 meter below the top of the pillar at the value of comprehensive strain of the top 3 meter segment of the pillar. First, we solve for velocity. The given is height is 0.30 meter and our area is 0.20 meter square. So the equation is volume is equals to area times height, which our area is 0.20 meter square and our height is 0.30 meter square and our velocity is 0.60 meter cube. And the second, we solve for mass, which our given is pillar mass is 2.7 times 10 raised to the power of 3 kilogram meter and our velocity is, volume is 0.60 meter cube. So our equation is mass is equals to pillar times volume. So our pillar is 2.7 times 10 raised to the power of 3 times 0.60 meter cube, which our volume, and the answer is 1.60 times 10 raised to the power of 3 kilogram. And for the third, we solve for the weight of pillar. So weight of pillar is, we use this equation of weight pillar is equals to mass times gravitational. So our mass here is 1.60 times 10 raised to the power of 3 kilogram times our gravitational is 9.80 meter per second square. So we come up with the answer is 1.568 times 10 raised to the power of 4 Newton. So for the fourth, solve for weight of the sculpture, which our sculpture is 1.0 times 10 raised to the power of 4 Newton. So our normal force equation here is weight of pillar plus weight of sculpture. So our weight of pillar is 1.568 times 10 raised to the power of 4 Newton plus our weight of sculpture here is 1.0 times 10 raised to the power of 4 Newton. So our normal force is 2.568 times 10 raised to the power of 4. So therefore the stress is equals to force, normal force divide area. So our normal force here is 2.568 times 10 raised to the power of 4 Newton and our area is, which our 0.20 meters square. So we come up with the answer of 1.284 times 10 raised to the power of 5 kPa. So and for the Young modulus naman, Young modulus granite is, we all know that Young modulus is 10 raised to the power of 10 Pa. So 4.5 raised to the 4.5 times 10 raised to the power of 10 Pa is equal to 4.5 times 10 raised to the power of 7 kPa. So strain is equals to stress divide Young modulus granite. So our stress here is 1.284 kPa divide our Young modulus, which 4.5 times 10 raised to the power of 7 kPa. So our answer is 2.85 times 10 raised to the power of negative 6 Pa. And for our example 2.12.8, stretching a rod. A 2.0 meter long steel rod has a cross-sectional area of 0.30 centimeters square. The rod is a part of the vertical support that holds a heavy 550 kilogram platform that hangs attached to the rod lower end. Ignoring the weight of a rod, what is the tensile stress in the rod and the elongation of the rod under the stress? So solution first is divide area, which are first have a equation of mass times gravitational divide area. So our mass here is 550 kilogram and our gravitational is 9.80 meter per second square. On our area, which is centimeter, we convert it into meter. So i-come up siya sa 3.0 times 10 raised to the power of negative 5 meter square. So ang atong answer is 1.8 times 10 raised to the power of 8 PA. And we continue to delta L. Delta L is equals to first divide area times L is represent our the long of the steel divide the young modular young modulus. So ang atong F divide area is equals to 1.8 times 10 raised to the power of 8 PA, and our 2.0 meter muna siya tong long of the steel, and our youngest modulus is 2.0 times 10 raised to the power of 11 PA, which i-come up with answer of 1.8 times 10 raised to the power of negative 3 meter or 1.88 millimeter. And for our sample 12.9, in a hydrolytic press, 2.50 liter volume of oil is subjected to a 2,300 pal pressure increases. If the compressibility of the oil is 2.0 times 10 raised to the power of negative 5 atm, find the bulk strain and the absolute decreases in the volume oil when the press is operating. So, bulk strain is equals to pressure times 160 atm. So, we all know that our pressure is 2.0 times 10 raised to the power of negative 5 atm, and our atm is 1.60 atm. We come up with answer of 0.0032. So, bulk strain is equals to delta B times volume, which our delta B is 0.0032 times our volume is 2.50 liter. So we come up with answer of 0.78 liter. Example 12.10. An old book shelf. A cleaning person tries to move a heavy old bookcase on a carpeted floor by pushing tangentially on the surface of the very top shelf. However, the only noticeable effects of this effort is similar to that seen in figure 12.24, and it disappears when the person stops pushing. The bookcase is 180 cm tall and 90 cm wide with 430 cm deep shelf, all partially loaded with books. The total weight of the bookcase and books is 600 Newton. If the person gives the top shelf a 50 Newton push that displaces the top shelf horizontally by 15 cm relative to the motionless bottom shelf, find the shear modulus of the bookcase. So we use the equation S is equal to shear stress divides stress strain, which force of the person divide area and the height of the bookcase divide delta x. So we have the given here the force of the person 50 Newton and our delta x is 15 centimeter. Our height of the bookcase is 180 centimeter. And our area is 30 centimeter times 90 centimeter is equals to 2,700 centimeter square. So, and we use the equation. So our force of the person is 50 Newton divide 2,700 centimeter, which our area, times 180 centimeter, which our height of the bookcase, divide 15 centimeter, which are delta x. So 50 centimeter Newton and 2,700 centimeter square ato sa naibutang. 180 divide 15 centimeter, which is 12 centimeters square. So, copy 15 Newton time divide 2,700 centimeter square divide 12 centimeter square. So, ato sa ni divide ning same og anang variables with centimeter square. So, 50 Newton divide 225. So, we come up with answer of 2 over 9 times 10 raised to the power of 4 Newton meter square. So, our answer is 2.222 kPa. Example 15.2. Determine the equation of motion for block and spring. A 2 kg block is placed on a frictionless surface. A spring with a force constant of 332 Newton meter is attached to the block, and the opposite end of the spring is attached to the wall. The spring can be compressed or extended. Equilibrium position is marked as the x is equal to 0 meter. Work is done on the block, pulling it out to x is equals to 0.02 meter. The block is released from the rest and oscillates between the x is equal to 0.0 meter and our x is 0.02 meter, which is negative. The period of the motion is 1.57 seconds. Determine the equation of motion. So, to find the value of W, we use the equation W is equals to 2 pi divide 1.57 seconds. Muna siya ang atong period of motion. So, we come up with answer of 4.0 seconds raised to the power of negative 1. So, we solve for B max is equals to area times W. So, our area is 0.02 meter and our W here is 4.0 second raised to the power of negative 1. So, we come up with answer of 0.08 meter per second. So, in the other, we solve the A max with the equation of area times W raised to the power of 2. So, our area here is 0.02 meter, and we all know that our W is 4.0 seconds raised to the power of negative 1 square. So, our answer is 0.32 meter per second square.